You've probably noticed that our builds are fairly slow. Every time we make a small change, we have to rebuild and wait almost half a minute. So let's see how we can optimize these builds. The first thing you need to understand here is the concept of layers in Docker. An image is essentially a collection of layers. You can think of a layer as a small file system that only includes modified files. So when Docker tries to build an image for us, it executes each of these instructions and creates a new layer. That layer only includes the files that were modified as a result of that instruction. So for our first instruction, Docker is going to take the node image and put it in a layer. Now, more accurately, the node image itself is several layers. But let's not worry about that for now. Let's just imagine we have a single layer, and this layer includes all the Linux and node files. Then Docker is going to execute the second instruction to add a group and a user. Once again, it's going to create a new layer because as you saw in the previous section, when we add a user or a group, something is written to the file system. So a couple of files are modified. So this layer will only include the modified files. Okay. Similarly, Docker will execute all these other instructions and create several layers. Let's have a quick look at these layers. So here in the terminal, we type Docker history and the name of our image, React app. All right, let me move this window around so you can see things clearly. Okay, we're only going to look at these two columns, created by and size. In this column, you can see the instruction that created a new layer. And in the size column, you can see the size of that layer. Now we have to read this list from bottom to top. So look over here. First, we have this group of layers that come from Node and Linux. So earlier I told you that when we use the from instruction, that instruction is going to bring in several layers that belong to Linux and Node. And then we're going to build on top of those layers. Okay. Now look at our run instruction for adding a new user. That's the command that we typed earlier, right? Now look at the size of this layer. It's 4 kilobytes because only a couple of files are modified as a result of this command. Now look at how this instruction is executed. It's executed inside /bin/shell because we use this instruction in the shell form. In contrast, if we use the execute form, this command would be executed directly, okay? Next, we set the current user. The size of this layer is 0. No files are changed. Then we set the working directory. Then we copy all the application files. And over here, you can see the size of this layer is 1.6 megabytes. Then we run npm install. And once all these dependencies are installed, they are stored in this layer. And the size of this layer is 178 megabytes. So an image is essentially a collection of these layers. So you understand what layers are. Now, Docker has an optimization mechanism built into it. So next time we ask Docker to build this image, it's going to look at the first instruction and see if the instruction is changed or not. If it's not changed, it's not going to rebuild this layer. It's going to reuse it from its cache. That's the optimization I was talking about. Then Docker is going to look at the second instruction. Once again, nothing is changed here, so Docker is going to reuse this layer from its cache. In contrast, if we made a tiny change here, let's say if we changed app to app2, then Docker had to rebuild this layer, okay? Now, look at this line. Copy all these files. This is a special instruction because with this instruction, Docker cannot tell if anything is changed or not. So it has to look at the content of files as well. And that means if we make a tiny change in our application, if we write one extra line of code, Docker cannot reuse this layer from its cache. It has to rebuild it. And this is where the problem happens. Once the layer is rebuilt, all the following layers have to be rebuilt as well. So Docker cannot reuse this layer from its cache. It has to install all npm dependencies. And this is exactly where we have a bottleneck. We have to wait half a minute for all these dependencies to be installed. It doesn't make sense. So to optimize our build, we have to separate the installation of third-party dependencies from copying our application files. How do we do that? Very easy. Instead of copying all the files in one go, first we want to copy the files needed for installing third-party dependencies. Do you know which files I'm talking about? These two files, package-lock.json and package.json. These are the only files that we need for running npm install, okay? So we're going to copy package star.json. Then we run npm install. And finally, we copy all the application files. Now, with this new setup, if we haven't changed any of our application dependencies, Docker is going to reuse this layer from its cache because package.json is not modified, right? Similarly, Docker is not going to reinstall all npm dependencies because this instruction is not changed. If it changes to npm update, then yes, Docker had to rebuild this layer, okay? But nothing has changed here, so Docker can reuse its cache. Then we're copying our application files, and of course, this layer should always be rebuilt, and that's totally fine. So let's run a quick test. Back to the terminal, let's rebuild this image. All right, now look over here. On this line, you can see cached because Docker is reusing the layer cache for this instruction. The same is true for setting the working directory. Now, this is the first time I'm building this Docker file. That's why this is a new layer that we have. This layer has to be built. And of course, dependencies have to be installed as well. So let's wait until this is done. All right, the image is built. Now let's go modify our application code and do another build. So I'm going to go to this file, readme.amd, and add a plus here. Very simple. Now let's do another build. All right, our build was super fast because we didn't have to wait for the installation of third-party dependencies. Look at this line. Once again, we are using layer caching. So here's what you need to take away from this lesson. To optimize your builds, you should organize your Docker files such that the instructions that don't change frequently should be on the top, and the instructions or files that change frequently should be down the bottom.